In this project, we look at building a fully functioning end-to-end project using distributed ledger technology. This will give us the intuition for the application of the technology as part of the shift to Web3 and how this ecosystem can be used to offer online services. However, I'm not an expert and this is not a tutorial. That said, I hope you're able to gain an intuition into this very exciting area of technology and go on to consider what you could do with it. An on-chain example is Ethereum. It is a network made up of decentralized computation and storage. It has a cryptocurrency, also called Ethereum, that allows users to pay for using the network with what are known as gas fees. Special programs called smart contracts can be uploaded and run on the network. These smart contracts enable users to securely interact, such as tracking digital ownership with non-fungible tokens or representing real-world assets on-chain, e.g. USD Tether. Every user accesses the network via a digital wallet that is unique to them. It is the identity that allows them to interact with the smart contracts, other users, and it also holds their digital assets. In combination with the Internet and web services, all of this is brought together as distributed apps or dApps. These allow complex on-chain services to be built. In this project, we will show how such a service can be built that allows a seller to create and trade financial contracts and then settle any resulting value via the distributed network. Someone has an asset that they want to trade on-chain, a commodity like whiskey or art, or tickets to a concert, or perhaps contracts such as car insurance or financial products. To trade this on-chain, the owner will create or mint a non-fungible token, which is a type of smart contract. Every NFT has an owner, defined as a wallet address, and an immutable or unchangeable digital link to the asset. So whoever is the owner of the NFT is the owner of the asset linked to that NFT. The critical point here is that the NFT has to be recognized as titled to the asset by the legal jurisdictions in which the buyer and the seller are governed. Now, when the NFT owner is changed, it is considered as legal change of title to the asset. So the trade happens when the buyer passes a digital currency to the seller and the seller updates the NFT owner to be that of the buyer. When we settle value on chain, we could use crypto coins such as Bitcoin. However, crypto coins can be very unstable in terms of their equivalent value in real currencies. So, there's been a growth in the use of stable tokens. A stable token is a token that is backed by a real asset. The token issuer guarantees to hold in a secure escrow account the same amount of real asset as there are tokens issued on-chain. This way, 1 unit of the stable token should then always be worth exactly the same as 1 unit of the asset it was backed by. We can now introduce and trade on-chain digital versions of any asset that we choose: currency, shares, property, etc. The main risk is that we need to trust the entity that is backing the token. So in this way, a stable token is not exactly like the asset, as we have counterparty risk to the token issuer. Standards help build interoperability between parties. So, there are emerging standards for smart contracts. In our example, ERC 721 for NFTs and ERC 20 for tokens. These standards are nothing more than a common set of capabilities a smart contract offers. However, as these capabilities have a common interface, it means any service such as a digital wallet can work with any smart contract that meets that standard. So, ERC 721 is one of the basic NFT standards, and ERC 20 is the token standard. In our project, we issue all NFTs as ERC 721 and all tokens as ERC 20. This allows MetaMask, as a third-party wallet, to understand how to hold and work with these items. This is then the basis of how a distributed system can grow, with many providers of standard contracts, NFTs, settled with many standard assets, tokens, across many users using standard wallet services. So, in our demo, we're going to show how a seller can offer financial contracts where the value depends on other assets such as share prices. If a buyer wants to enter into the contract, they will pay a fee in the form of a stable token. Then, if the contract has any value in the future, the seller will pay the buyer in terms of a nominated stable token. However, as we are using tokens, we can choose to be paid in any token backed by any asset, currency, shares, etc. When the buyer enters into the contract, the seller will create an NFT that represents those terms and transfer the ownership to the buyer. This is the point of binding agreement. Then, at some point in the future, the buyer can exit the contract by transferring the NFT ownership back to the seller in exchange for any residual value. The seller finally destroys the NFT as it no longer represents any binding agreement. Let's see how this is implemented as a fully working project. There are 3 key elements: the Ethereum chain, a cloud-hosted web server, and the internet-accessed web application and digital wallets. There are 4 types of accounts or wallets: the buyer and the seller, the account that creates the on-chain currency and share tokens, and finally, the account that publishes secure prices. We then have the user interface that drives the process, supported by the web server. The web server is responsible for storing the agreed option terms. In the spirit of decentralization, it does this using the Interplanetary File System, or IPFS. The web server is also responsible for creating, or minting, a new NFT for each new set of option terms. To value the contracts, we need some market prices. So, the data provider wallet digitally signs them and injects them as updates available via secure smart contracts. To trade on-chain, we on chain money. In this demo, we create stablecoins, which are currency-backed tokens. This means we can create a proxy for any currency and use it on-chain to settle any debt. In our demo, we would also like to show how we can create contracts that deliver shares. So, we create stable share tokens backed by real shares. So now we have a way to create on-chain contracts and settle value as currency or shares, where the wallets of the buyer and the seller can drive the transactions and hold all of the tokens and NFTs. Okay, let's first do a tour of the user interface. On the first tab, we can see all of the accounts, the wallets, and the on-chain assets they hold. These accounts are on a test network, and the on-chain assets are test balances that we've created. We can see a combination of stable coins and stable shares. As we do the demo, we will see these on-chain balances changing as we buy and sell the contracts. In practice, these accounts would be secure and only accessible to the people and companies that controlled them. We use MetaMask as a third-party wallet service to switch between the accounts. The application will then change its behavior based on the active account. On the second escrow tab, we can see the stablecoin and stable share smart contracts that we have created. We can see the test balances that were set up for the demo. The smart contract show as balanced when the asset backing the token is the same as the token supply. In practice, this would be verified by an independent auditor of the stable token issuer. In the Prices tab, we can see the secure on-chain prices that are used to value the contracts. The color changes reflect up and down movements in the prices as they're being updated on-chain. In the bottom right of the screen, we can see an overlay of the prices being injected and the corresponding activity on the test chain as the calls to the secure price smart contracts are being made. We are signed in as the seller's wallet, so let's create a contract and offer it to buyers. The key point of this demo is that it could be any type of contract: financial, commercial, flight details, etc., where a seller offers some terms and a buyer pays a fee or premium to enter into the contract. Then, at a later point, the buyer uses the contract to make a claim, take a flight, or otherwise settle its value. Let's create an option that's based on the Apple share price. If the option goes in favor of the buyer will be given the value as Apple stable shares. The premium we set to 100, paid as USD stable currency. The notional, 150. We then set the reference level against the secure on-chain Apple price. Then, if the price goes above 160, it will generate value for the buyer. And finally, we set the contract to settle to pay as Apple stable shares. We now offer the option so that it's available to the buyers. At this point, the contract doesn't exist on chain. it has just been saved on the web server where the buyers can see and purchase it. If we connect as a buyer account in the buyer view, we can see the offered option. Then, if we buy the option by transferring the required USD stablecoin amount to the seller, the option will appear in the list of options we own. In the console window at the bottom, you can see the NFT number 26 being created and linked to the terms. This NFT is then transferred from seller to buyer. So now we see the newly created NFT number 26 in our list of options, and it matches the terms of those originally offered. The contract is now saved in the distributed third-party file system called IPFS. An NFT has been created and is linked to the terms in IPFS and also an on-chain contract option. This contract option calculates the value of the terms by linking to the on-chain secure price. This means the terms are immutable and the price is secure, so both the buyer and the seller can be confident of the contract and its value. We can connect to our web server to see what's going on behind the scenes. First, we ask the server to list all of the options it knows about. For each entry, there is a hash of the terms, which is used as the IPFS name and is also how we verify the option terms are never changed. We can rehash the terms and compare to the original hash that's locked inside of the NFT. If we request a specific option, the details will be pulled back from IPFS as seen here. You can see the tokens and other on-chain details are represented by their unique contract address as they appear on-chain. This allows the web server to make calls to those elements when performing actions that relate to the NFT and the contract. As a buyer, we reach a point where we want to realize the value in our contracts. To do this, we exercise the contract. In the console window, we can see the exercise process, the value being settled and the NFT being destroyed. There is a slight delay as it takes a while for the chain to validate the transactions. This contract's value is 1425 USD. This is because the contract value is defined as the difference between the current Apple stock price and the strike of 160, all multiplied by a notional of 150. However, we have nominated settlement in Apple stable shares, not USD, so we divide 1425 by the current price of 169.68, which gives approximately 8.4. So, when we exercise this option, the seller will transfer 8.4 Apple stable shares to our wallet. We can see this if we look at the before and after values in the account view. The key here is that this has all been conducted on-chain with standard tokens and NFTs, so we have shown a viable basis for a more sophisticated ecosystem of general contracts and settlement of value in any asset we can tokenize. Let's do a quick tour of the project. We start with the GitHub repo. Here, we can see all of the contributors who came with excellent input, such as the use of IPFS and Material UI. If we scroll down, we can see the overview for starting up and testing. In addition, the link to the detailed GitHub pages. The key links are, first, the overview that describes the goals and designs of the project, and second, the notes on deploying and running the test environment. This can be done standalone on any machine, as we use all locally run test services. Finally, we can have a look at the code. The contract section is all written in Solidity, which is a language that can be deployed on-chain to Ethereum. It has a number of specific features around security and which wallets can call which methods. Here we see the code for a simple option that is used to value a contract. We can also see the front end. This is written in JavaScript, React, and Material UI. It binds together the interaction with the web server, as well as direct on-chain calls to the smart contracts. We then have the web server, also written in JavaScript. This manages the saving and loading of option contracts and all other support needed by the UI. Finally, we have a detailed set of automated tests. Once a contract is deployed on-chain, it cannot be modified. Also, if the contract has a bug that allows assets to be stolen, it's clearly a huge risk for the entrepreneur. So, a rigorous set of detailed and automated tests is absolutely critical. Here we see the automated test running, verifying all key aspects of the contracts. It just remains to say thanks for watching, and we hope this has been in some way helpful and informative.